Every time you sign up for a service that requires ID verification, you're uploading your documents and trusting that the company handles them securely. This happens across so many services. Think banking, purchasing goods, so on and so forth. Dokimos fixes that with one simple idea. If you verify once, you're trusted across all these services and platforms. And you upload your ID only one time. It gets processed inside an Intel TDX, secure enclave powered by EigenCloud, and what comes out actually isn't your document, but rather a cryptographically signed proof of very specific attributes about you. And you own it and also control who gets to see it. Let's start with the user side. After signing up, you upload your ID just once. The ID goes into the trusted execution environment running on EigenCloud. And the first step is in the TEE is an OCR of all the character fields in the license or ID itself.
Okay, so the second step is to actually make sure that the ID that's being uploaded matches the person who's actually uploading the ID, which is why we have a live selfie check or live face check. So because I'm not Janice, I'm Wizard of Ozing it for this demo, but in production, this is an incredibly important feature to make sure that Dokimos isn't used in malicious or harmful ways, and definitely extensive work will have to be done for this facial algorithm met with and matching it to whatever the photo is that's from the ID and taken out of it. So after this step, this is the second piece of data that goes into the trusted execution environment.
After the onboarding is complete, this is your vault. You can see exactly what just happened and actually verify this information yourself on the verifiable build dashboard. You can see exactly what attributes you've been verified for, and you can also approve and deny company requests right here. But here's the thing, Dokimos only works if it's a two-party product. Customers need businesses to adopt it too. So for me, I built the business side as well. Let's say Airbnb. Businesses can create different verification workflows depending on what they actually need. For example, a host verification asks for different attributes than a guest check, and only those attributes get requested. That's selective disclosure built into the product. Now, I'm sending a request to Janice. She can see exactly who's asking, what they'll see, and what they want from her ID. For the first time in the current ID verification system, she's in control of her data. Janice approves, and on the business side, you can see that it's verified instantly. It also shows up in her activity, and now she has a log of all the places she shared her personal identifying information to. But I want to pause here because this is what makes Dokimos different. Airbnb doesn't have to trust Dokimos. I actually built a 5-step guided verification flow so that any counterparty can confirm that the attestation is real, and they can do this independently. The first step is signature verification on Etherscan. The TEE never signs raw identity data. It hashes the attributes into a cryptographic fingerprint and signs that hash, so the proof is public, but Janice's data never is. We copy the wallet address, message, and signature into Etherscan's verifier. It actually confirms that the hash was signed with this wallet on public infrastructure. The second step is verifying the Intel TDX infrastructure. We can go to EigenCloud's verifiable dashboard for this app, and you can see the platform is not only listed as Intel TDX, but you can see the genuine TDX measurements are present as well. This means that the deployment is running on real protected hardware. That's an additional security guarantee EigenCloud provides to its users. Step 3 is checking that the wallet belongs to the trusted execution environment. This wallet isn't sitting on a laptop somewhere. It's actually mathematically derived from a mnemonic managed by EigenCloud's KMS, and it only exists inside the TE. So on the dashboard, under derived EVM addresses, it should be there, and it is. So the same wallet is in 2 places, and it's cryptographically bound to this very specific EigenCloud deployment. The fourth step is checking the verifiable build. The repo is public, and anyone can read exactly what the code ran inside the enclave. This step shows that to the user. And it means that because this is a reproducible build, anyone can clone the repo, build a Docker container themselves, and verify the container has matches. The code that's running is exactly the code that's public. Those 4 steps prove to a user that has never seen crypto that this information lives permanently on a public blockchain. The signature is real. It came from a genuine Intel TDX hardware, and the wallet is cryptographically bound to this deployment. So the code that ran it is public and auditable by anyone. No one had to call Dokimos to confirm it, and no one had to trust a privacy policy. The proof quite literally verified itself. And I think that's what makes this infrastructure genuinely new. There are 3 things that have never been possible together before. The proof is produced inside the hardware no one controls, not even us. It's independently verifiable by a complete stranger without any trust in Dokimos. And the source code that produced it is public and auditable by anyone. No traditional identity service can offer all 3 simultaneously. They all require you to trust the provider at some point in the chain. And I think that foundation opens up something bigger. The next frontier in agentic applications are AI agents acting on behalf with counterparties you've never met. For that to work, the agent's actions need to be provable and not just trusted. What I built here is the identity layer that makes that possible. Verify once in a trusted execution environment, and every agent downstream can carry that proof to any counterparty anywhere. And that's exactly what EigenCloud makes possible.